Okay, right now we're going to talk about section 1.6, and this is going to be part one. We're going to talk about vertical translations, horizontal translations of graphs, and reflections over the X and Y axis. Okay, so I'm going to give you a little bit of notation. If my original function is f of x, my transformed function for a horizontal translation, we're going to use these letters a lot. Sometimes we've used H and K for vertex. So H could be horizontal translation, K is vertical. In function notation, this book is going to use C. So this is translation right C. And when it is inside the f of x or inside the function part, that's going opposite the sign. We did this with circles. This is left C. Vertical is going to be outside, and it's going to go with the sign. They use C again. I don't want to use C. I want to use D. Would prefer to use a different letter, so I'm going to use D, even though the book uses C. This is down D. I'll make that D a little further away, make it a little clearer. So here's an example. My original function is y equals the absolute value of x. Its graph looks like this V. You can verify that with your graphing calculator if you need to. I'll show you how to do absolute values in a second on the graphing calculator, but you probably should know how to do this translation anyways. In function form, I can write it like this, which translates to equation form like that. So this is called function form. I'm not going to make a huge deal out of this, but this is equation form. Most of the things we do will be in equation form. And what does this -4 outside do? Shift it down 4. This graph looks like that. Same V. They should be parallel. Might not have been perfect. I can also do x plus 2. That's in function form. In equation form, that's x plus 2. That should be an absolute value, not a parentheses. So what does that do? Shifts it left C, which is 2. And there's my basic translations. So I'm going to show several of them with the graphing calculator. So my basic function, and this is example 2. They say y1. I'm going to call it f of x equals x cubed. We're going to modify this. Actually, I'll show you their notation because it's a notation that might come up in the future. Y2, or f, is going to be x cubed minus 3, which they're going to notate in function notation y1 of x, and then minus 3. So they're essentially using y1 to be f. I'm going to call what they call y2 again in part B, I'm going to call y3. X plus 2 cubed y1 of x plus 2 and y4 x minus 3 or y1 of x minus 3. So my original cubic looks like this. This one, I got a minus 3, so I'm going to shift it down 3. This one, I got a plus 2. Inside means left, right, and opposite the sign, so I'll shift it over. My last one, I will shift opposite the sign again, so right 3. And let's take a look at all of these on the graphing calculator. And we'll see that they do all, in fact, come out to what I'm showing. So my original here was purple, so I'm going to put it in as purple. Nope. X cubed was my original. My second one I did in blue, which was x cubed minus 3. My third one I did in red, which was x cubed. Oh, nope, I need parentheses around this. X cubed, no, x. Struggling to enter this one. This was x plus 2. My last one was green, which was x minus 3. I have to use the X button on the calculator, not on my keyboard. But the only reason I did them in this order was to match the colors I did on the Zoom. So, or on the rest of the video. So I'm going to go Zoom standard. I don't know what Zoom I'm in, but before I graph. So purple was the original, then down 3, over 2, and right 3. And those are translations left, right. I'm going to go back to the whiteboard and we're going to talk about reflections across an axis. So the reflections, and one of the keys here is reflections happen before translations. I'll put that in a darker color. Reflections always happen before translations. And I'm going to say over the x-axis or across the x-axis and across the y-axis. I've heard in x-axis, and that really means like it might if you can just like translate your axis with things and reflect across that, but it ends up being a little harder usually. So reflections happen before translations. And a lot of times you've just thought of it when you have a parabola as it goes to this point and opens down. That is a reflection across the x-axis. So for x-axis, you add a negative outside your function. For y-axis, now with a parabola, reflection across the y-axis doesn't do me anything. Okay, so we're going to look at a couple of reflections. So here is f of x. There's my original. Now I'm going to look at negative f of x, which really means I just added a negative. And then the one that's a little harder. So this is just a reflection across the x-axis. F of negative x means I have to plug a negative in for both my x's. Five times negative x is just negative 5x. Nothing gets changed on the 9. Negative x squared is the same as x squared. Whenever I square a negative, I get the positive. So we're going to take a look at these three functions on the graphing calculator. This is a little bit of an interesting function. So reflecting it across the x-axis means I'm just going to flip it. Let's undo my... So it means I'm just going to take my graph. If it's up here, I'm going to flip it, if this is the x-axis, to down here. And let me show you that these three on the graphing calculator. Okay, first thing I need to do is clear all of these out. And again, I'll match the colors that I did on the whiteboard. So the original I did in red. And I'm going to use this. This is really handy on the CEs. Alpha of the X button gives me a fraction. Deleted too much. So 5x minus 9 over x squared plus 3. And first thing, I'm just going to take a look at that graph. I'm still in Zoom standard. So here it is, right, like that. Now, to take a look at its reflection across the other axis, I'll go back and I'll put in negative. I have to actually use the negative button, can't press the minus sign. Kind of wish I could connect my calculator and just type on that instead of having to use a mouse, but that's okay. X squared plus 3. And there we've entered it. And you can see it's exactly flipped across the x-axis, not the y-axis, the x-axis. I'm going to hide this one for a second so I can just see the flipped across the y-axis, which I believe I wrote in purple. So I'll use the purple one. And that was the formula. So in order to hide the blue one, all I did was come here and highlight the equals. I hit enter to turn it on or off. When it's not highlighted, it's off. So I just have the red and the purple one showing. And we can see that they are reflections across the y-axis here. Okay. And that is how far we're going for today. We'll talk about stretching and shrinking the graphs tomorrow.